Hi class. In this video, we're going to talk about chapter 2 of your textbook. So the title is Thinking Like an Economist. So let's get started. All right, so economics. Economics is science. If you look at your course listing in your college, then you're going to realize economics is in the same department as sociology, psychology, history, government. So it's a social science. And the reason why economics is a science is that because economists, what we do is that we do many we use scientific method to use theories to actually test theories. We're going to collect data and actually collect many data. There's a website called bls.gov. If you go there, you can look at the data collection we have for our economy, all the way back to the early 1900 on the price of almost everything. So we collect data and then we also analyze the data, and we use computations, use regressions to see if there's any correlations between the data, and then use those findings to test our theories. So which means economics is a science. Okay. Now, we all know what scientific model is. You guys all learned this in your grade school, so I'm not going to go over this. So the rule of assumption. Now, remember what I said before in chapter 1, that in this class, I want you guys to think within the box. And then right now for you, the box is very small. So for many models we learn in economics, that the model is good when everything else holds constant. So we're going to make some very big assumptions. So every time we're talking about different examples, different variable change, assuming nothing else change. And once you do that, you're gonna make your life much simpler. Okay, so don't think too much. When you think about these individual problems, think within the box. Okay, all right. And for economic models, so in this chapter, we're gonna learn 2 economic models, and then for this semester, you're gonna learn many economic models, and they're like equations, graphs, diagram. We're gonna look at it, and then you're gonna realize that these are very simple models. Now, again, the reason why we keep it simple because you put too many variables in it, it's hard to explain all the variables. I mean, imagine if you have a 2D graph, so x and y, and then you can look at the correlations very easily, if it's a positive slope or a negative slope. Now, imagine if you go a step further, you do a 3D graph, so x and y and z. And then, you can still see the correlation between variables, but it's not that easy anymore. Now, imagine if you have a 4D graph. Here's a picture in your head. Okay, so imagine a 4D graph in your head. All right, stop. Don't hurt yourself anymore. All right, so it's not, you can't. Our head is not built that way. So the reason why we keep it only 2 variables, very simple, to make the study of economics much simpler. Okay. All right, so let's look at our first variable, first model. It's called a circular flow diagram. So it's a very simple model that shows you the economy, a very basic view of the economy. It shows you how money flows between household and firms, and also how good and service flow between household and firms. So in this very simple model, there are only 2 decision makers. So two variables. Now these 2 parties, they're the firms and household. And then for this market, for this diagram here, we also have 2 markets. We have the market for good and service. That's everything you buy, and then something called the factor productions. So two different players, firms and household, and 2 different market. You have good and service, and then factor productions. Now, before we go to the next slide, I want you guys to think about this question: that between firm and household, who is on the demand side? So between firm and household, which one is on the demand side of the economy? Now, you might be thinking that household, we buy all the stuff. We want to buy stuff from companies. Therefore, household, we're on the demand side of the economy. Now, that is partially right. The reason why that is because we have 2 different markets. Now, for the first market, for the market for good and service, and you're right, because in the market for good and service, so stuff you buy from stores, like your shoes, your jeans, your t-shirt, in that market, your household, we're on the demand side. We want to buy those stuff. But firms on the supply side, they sell the stuff for us. But for the second market here, the market for factor productions, then this one is reversed. So what are the factor productions? So if you look at your notes in your book, so factor productions, there are labor, your capital, And I'm forgetting one thing. What am I forgetting? Oh, land, your natural resource. All right, so this is three factor production. So labor is our workers. So your employees in the company and also the human knowledge, that's your labor. Now capital here, this is a little tricky. Now this capital, this is your physical capital. So your machineries, your cars, your buildings, and your tools you have in the company, they're all the capital we have. Now, what's not in the capital is money. Now, remember this, money is not a factor production. And the reason why that is, now remember I mentioned this in chapter 1, that you guys don't need money. Same thing for the companies. They don't need money. They need what money can buy. So even though money is very important for companies, but money is not factor production. Okay, and the last one, land. What land is your natural resource. So your water, your wind, your coal, your gold, your oil, all those natural resources, they're in a category for land. So you have three factor productions here: labor, capital, and land. And then depends on different textbooks. There's one more. It's called entrepreneurship. So entrepreneurship is the ability for individuals to gather all the factor productions, your labor, land, and capital, run a business and take on all the risk and then enjoy all the profit. So there might be a fourth one. It's called the entrepreneurship. Okay. All right. So firms produce good and service. So they're the supplier for good and service. And then they will use factor productions. So again, your labor, land, and capital. So firms, they demand your factor productions to supply your good and service. And a household is reversed. So they're like the two sides of the coin. So household is everything reverse of firms. So household, we have the factor productions. So we are the labor. We own all the land. We own all the capital. And then we're going to supply those to the companies. And at the same time, when we go to the good and service market, we're going to buy good and service. Okay, so if you look at this diagram here, well, one more information, so very important. Remember, firms are the sellers for good and service, household the buyers, and then for the other factor productions, remember this is your labor, your land, your capitals. Here is reversed. Firms are the buyer for the factor productions, and the household are the seller for factor productions. So when you think about between firms and household, who's on the demand side, who's on the supply side, be very careful. Okay, so make sure you know which market you're talking about. In the market for good and service, it's the firm, the supplier, household, the buyer, and then for the market for factor productions, that's reversed. Your firms become the buyers, and the household become the sellers. So let's look at this diagram here. So this diagram here is called a circular flow diagram. Now let's look at the firm first. So for firms, they produce the good and service, and then they will sell the good and service. And then at the same time, they will hire factor productions. So what the firm will do, the firm will first go to the market for factor productions. They want to hire workers, and then they will pay workers with wage, rent, and profit. And this money will be in turn given to our household. So household will take the money, we call this our income. Once we have the income, we're going to go to our market for good and service here. We're going to spend our money, so buy good and service, whatever you want to buy, and then this money will be in turn given back to the companies as a revenue. So this outer layer, this green arrow here, shows you the flow of money. So flow of money, first it goes from firms to the market for factor productions, and then from there, we'll call them income given to a household. Household take the money, buy more stuff, and then money flow back to firms. So the green arrow shows you the flow of money, and then the red arrow here shows you the flow of resource and good and service. So again, remember household, we own all the good and service, and we're going to sell good and service. So we're going to go to our market for good factor productions. Wait, what did I say? I'm sorry. Did I say the other way? Household, we own all the factor productions. We're going to sell all the factor productions. So first, household, we're going to go to the market for factor productions. We're going to supply our labor, land, and capital. And then this will be used by the companies as a factor production. They use them to produce good and service, and then they will sell good and service in the other market. And then we're gonna buy it, and then those good and service flow back to our household. Okay, so the inner circle here representing the flow of input output, The outer layer there, outer circle there, representing the flow of dollar, the money. Now, guys, you will see questions like this on the test. So I might give you a little diagram here and then ask you which party is on the supply side, which party is on the demand side for which market. Okay, so make sure you remember that for the market for good and service, firm supply, household demand, and then for the market for factory productions, it's firm's demand, household supply. All right. Now, the second graph, the second model, which is very important, I'm going to use this in the next chapter, it's called a production possibility frontier. So this one, we're going to do a X and Y graph, so two-dimensional. And then what it does, it shows a combination of output that the economy can possibly produce. So this word here is very important. Now, this production possibility frontier doesn't show you how much the economy actually producing. It shows the potential the economy can produce. So the combination of two goods, so X and Y's or apple and bananas, combination of only two goods, how much we can produce them at maximum possibilities. And then this will given your fixed number of factory productions. So it's fixed, your number of labor doesn't change, number of land doesn't change, and then also you have fixed technology. Okay, so with this, again, what this graph shows you that between two good X and Y's, how much we can produce a maximum given the available technology and the available factory productions. So let me show you what it looks like. So for this will be a typical production possibility frontier. And then we're going to put each good on each axis. So on here on the vertical axis, we have our number of computers produced. And on the horizontal axis, with number of cars produced. And then this blue line here, this is called the production possibility frontier. Because what this line shows you, it shows you that as long as you are on this line, how many cars and how many computers can produce in the combination. So for combination A here, we can produce 2,200 computers and 600 cars. And then combination B here can produce 2,000 computers and 700 cars. So it shows you how much you can produce a maximum. Now, can we produce more than that? So can we produce a point C here? Well, the answer is no, we can't. Because for point C, that's more than our possibility. So for any point that's outside the curve here, as long as outside, for this point C, we call this point impossible or unattainable. Because for our economy, we don't have enough resource, we don't have enough technologies to produce at this point C. That's just asking too much from the economy. Now, however, at point D, is it possible? So we have this 2 point A and B. Now, if you compare A and B and then point D here, can we produce point D? So can we produce in one time frame, can we produce 1,000 computers and 300 cars? I mean, sure we can. Because we can. If you can do A and B, you can do D. Because D is less than A and B. But if you produce at point D here, that means you're producing less than your potential. Now we could do more, but we're not doing more. We're actually doing much less. So for this point D, which is inside of the curve, and then for any point that's inside the curve, we call them inefficient. Because for this points inside the curve, we're not using all the resource we have. So points outside, we call them impossible because we don't have enough resource or technology. And then points inside, we call them inefficient because we can do more, but we're not doing more. So which means there are some resource that's left unused. So where you are on the graph here can tell you how efficient the economy is. Now, as long as you are on the line, we call them efficient. Because on the line, we're using everything we have. And outside, we don't have enough resource. Inside, we call them inefficient because we're not using everything we have. So that's what you can tell from this graph over here. And another thing that this graph actually shows you, it shows you the trade-off between each production possibilities. So let's compare this point A and point B. Now, point A, you have 2,200 computers and then 600 cars. At point B, you have 2,000 computers and 700 cars. So if you go from point A to point B, then we're going to increase our number of cars by 100. However, we lose 200 computers. So this trade-off here, that means you gain 100 cars, you lose 200 computers. This is called the opportunity cost. Now, remember we talked about this before in the first chapter. The opportunity cost is what you give up in order to obtain something else. So from this point A to B, in order to obtain this 100 more cars, we must give up 200 computers. Off here, it shows you the opportunity cost between each production combination. Now, if you do it reverse, if you do it from B to A, you have similar information. So from B to A, we gain 200 computers, but we lose 100 cars. So the opportunity of 200 computers is 100 cars. Okay, so again on this graph here, between different points, you can see what is the trade-off and what is the opportunity cost between different level productions. Now, on your test, on your quiz, you're going to see a straight line PPF. But on this one over here, on your PPF, by the way, PPF stands for Production Possibly Frontier. So on this graph here, PPF is border outward. And the reason why it's border outward, because sometimes you have specialized resource that's good in one thing, but not good in everything. So when you have specialized resource, their production possibility is curved outward. Okay. Let me show you example. All right. So suppose we have two individuals. Let's say I have a company, and then within my company, I have two. For this company, all we do is translating papers. So let's say we have person A, and we have me over here. Well, I don't want to call myself B. Let me call myself X. All right. So all we do is translating papers, and then for this business, we can either do English paper or Chinese paper. All right, so let's suppose our employee A, he is very good at English. So in 1 hour, he can translate 10 English paper. But he's not so good in Chinese, 2 Chinese paper. Now, me over here, I can do 2 English and then 10 Chinese. Oh, what just happened? What just happened? Here we go. Go back. Let's draw the PPF for this company over here. So for the PPF, remember for each axis, I'm gonna do one good on each axis. So let's say we do the English paper on the vertical axis, and then do the Chinese paper on the horizontal axis. And I'm gonna put the maximum number of production on each level of output. So for English paper, if everybody, so between person A and me over here, if everybody do English, he does 10, I do 2, so within an hour we can do 12 English paper. Now on the other extreme, if everybody all do Chinese, then A can do 2 Chinese, I can do 10 Chinese, then together we can do 12 Chinese paper per hour. Now the tricky thing is this point in the middle. So suppose we have both English paper and Chinese paper to work on, and if our company is very efficient, then we should let person A to work only in English, and then let me over here only work in Chinese. That within 1 hour, together, we can do 10 Chinese and 10 English paper. So if you draw this point here, 10, 10, so that point will be right here. So now if you draw your PPF, so connecting the dots, and that is your PPF. And if you look closely, you see how this line is like border outward, right? The reason why it's border outward because we have this specialized production. The person A is good in English, and then me over here is good in Chinese. Another information that this border outward PPF shows you is that your opportunity cost is not constant. So remember this, that if you have a straight line PPF, so if your PPF is straight line, then your opportunity cost is constant. But if your PPF is border outward, the opportunity cost is increasing as the more good you produce. Okay, so again, one more time, if your PPF is a straight line, and more than often on the test, on the quiz, you will see a straight line PPF. So if it's a PPF straight line, that means your opportunity cost is constant. But if you have PPF that's border outward here, that means your opportunity cost is increasing as the more good you're producing. So let's look at this graph over here. So suppose right now we're at this point. So let's call this point A. At point A, my total production for English is 12 paper, and then total production for Chinese is actually 0 paper here. So A here we have 12 English and 0 Chinese. Now, if we go from A, let's say this point B, we go from A to B. At B, we have 10 Chinese. So from A to B, the opportunity cost is that to gain 10 Chinese paper, we must give up 2 English paper. So the ratio is pretty much 1 English for 5 Chinese paper, right? Because we gain 2. I mean, we gain 10. We give up 2, so it's a 1 to 5. Now, if you go a step further, let's call this one point C. So at point C, we have 0 English and 12 Chinese. Now, if you go from point B to point C, we gain 2, but we give up 10 English paper. So now from point B to C, the ratio is reversed. So in the beginning, from A to B, you have 1 English for 5 Chinese paper, and then from B to C, it's reversed now. It becomes 1 Chinese for 5 English. So as the more and more Chinese paper you're producing, the more and more English paper you're giving up. So that's why your opportunity cost, that this ratio here, is increasing as the more and more good you're producing. Okay, so that only happens when you have a bolded hour PPF. But if it's straight line, it doesn't matter how many you produce, your opportunity cost is constant. All right, make sense? Now, if you have more questions, always ask me. Okay, I know this is not the easiest concept, but I'll always ask me questions, guys. All right, let's keep going. So again, any points on the PPF, we call them efficient. Any points outside the PPF, they're called impossible. And any points inside, we call them inefficient. And then guys, trust me, you will see question like this on your quiz, on your test. Okay. All right, so we talk about this. Now, remember this PPF shows you your production combination given your available resource and available technology. Now, however, if you do have a technology change, then your PPF will change. So let's go back to our computers and cars. Okay, so we have this PPF here that shows you how much computers, how much cars you can produce. Now imagine that we have a technology advancement in the production for cars. So let's say we can build more robotics. They can produce cars more efficiently. Therefore, our production for cars will be increasing, or at least our potential can increase for per number of cars. So when that happens, so better technologies for production for cars, your PPF will be shifted outward along your car axis. So this will be your new PPF. So on the new PPF, we can produce more number of cars compared to before. So whenever you have this production possibility curve change, more than likely it's because either technology change or your factor production change. Now, vice versa, let's suppose our economy, instead of having just your technology change, but we have more number of workers. And let's suppose our number of workers can work in both industry. So that's your old PPF. Now, to show an increase in population that can produce in both industry, your new PPF will be shifted outward along both axes. So that will be your new PPF. Okay. All right, guys. So remember, if it's only one industry change, your curve is like a tilted along the whichever the axis is. But if the change affecting both industry, then your PPF will be shifted over along both axes. Okay. So in this case here, so technology advance in the computer industry, and only in computer industry. Therefore, your PPF is actually like tilted along your computer axis. And then notice this: the car industry here is still at the same point, but the computer industry is increased to a higher level. Okay. All right. So that's your production possibility frontier. And then next, know the difference between the microeconomics and the macroeconomics. Micro is study of the economy on the smaller scale, So individual companies, individual firms, individual market. So we look at how company behave in those market. So such as monopoly, oligopoly, perfect competitions, monopolist competition. Now in macroeconomics, it's the study of economy on the bigger scale. So like macro, like big, right? So information such as your inflation affecting the entire economy, unemployment affecting the entire economy, economic growth affecting the entire economy. So all in the big picture, that's called a macroeconomics. All right, now, also know this difference here. So difference between positive statements and then normative statements. So positive statement, they're the statement based on facts, numbers, stuff you can verify. We call them positive statements. Normative statements are based on people's opinion, based on people's belief, based on people's thinking. That's called normative statements. So let me give you an example. Now let's suppose, guys, I'm telling you right now that I'm taller than JJ Watt. Well, can we verify that? Sure, we can, right? We can measure each person. We can measure me, measure JJ Watt, and let's see who is taller, and then we can know the answer. Now, what if I tell you that, guys, I believe I'm more handsome than JJ Watt? Okay. By the way, you should agree to that, because if you want to pass my class, you have to agree to that. Okay. Now, that's based on my personal belief. That's based on personal opinion. So that's called a normative statement. So again, positive based on facts, based on numbers. Normative based on personal belief and personal opinions. Okay. I think. But don't worry about this. This won't be on the test. Yeah, that's pretty much all you need to know. All right, so that's it for this chapter. So guys, again, just like before, you have any questions, let me know, and I'll be more than happy to you. Okay. So if nothing else, I will see you guys on your next chapter. Bye-bye.